Namaskar. As part of the ICT paper, we will be discussing about the data networks that will include integrated services digital network, that is ISDN, then the lines which are generally used for data transfer in our home, digital subscriber line, then asynchronous transfer mode ATM, which speed up the connectivity with ISDN. Now data network, generally when we are talking about data networks, we come across with sending data over copper wire, which is used for telephone. I would like to request you to recollect that 140 years back, Alexander Graham Bell invented telephone, which generally two equipment connect by using a copper wire for transmitting sound signal across the wire. So all the telephone services are based more on the transmission of signals from one end to other end of the phone. That kind of old telephone system is called PODS, public old telephone system. And this module will be discussing that kind of connectivity, how telephones links are used for data communication. Some of the module we have discussed circuit switched networks, that is between two endpoints in different places are going through different interface points, and from the beginning end to the last end, that will be like a circuit at the time of transmission. And module also will include its use and the technology and the architecture used on all this. So generally signals are transmitted, so we have that circuit switched kind of network, and the dedicated circuit networks are created between endpoint. Then the same connectivity or telephone system is being enhanced with very good technologies to give high speed data network with T carriers. T generally is learned a term used in trunk exchange. So T carriers, that is T1, T2, T3, etc. will come, and SONET optical based network, optical based, that is fiber based network. This generally this uses this kind of packet switched or circuit switched network. So in packet switched network, ATM is very important. The other tools are like a frame relay, SMDS, and Ethernet IP packets used for this network in the computer. Scope of this module is restricted to ATM. Then how this network can use to connect a private network, etc. Look at the simple telephone network. In a telephone network, public network, a public carrier is used. That is one end, the equipment will be there. The equipment could be just phone or fax, or it could be a camera, even a computer. So these are the equipment which we generally see in a endpoint. People try to use. Telephones are used for generally talking. Computer is used generally for data transmission, and video conferencing cameras are used for audio video synchronization for video conferencing. And this will use either a common carrier from between these two endpoints. It could be circuit switch or packet switched. Now, in a dedicated circuit system, the telephones which we use at our home will be connected to the nearest local exchange. So the phone or computer, through a cable, it is connected to the local exchange carrier. From there, they will be having sophisticated network to the next local exchange carrier, that is the other end of the remote location where we want to talk to. So at one point, you will see that all these carriers are handling different kinds of signals or processing, but there will be a circuit created between these two endpoints to establish. For example, when I pick up the phone, I dial a number. The moment number get connected, that means the link is established. The circuit is complete for the transmission of our data. So similarly, the public carrier will even though look like a cloud in between this local exchange carrier, but it provides an independent connectivity between two endpoints. In switched circuit is that there will not be any complete connectivity. Instead of that, whenever it is required to connect, we use the electrical cable with a switch. When the switch is on, the complete circuit is completed. Like that, there will be so many switching points in between. And a circuit is used by switching this point in between. That's why it is called switched circuit system. And by using this mechanism, we can transmit or transfer voice signals, data, as well as video signal. And the difference is that voice signal may not take much bandwidth. The data also may not, but like a video conferencing kind of application may require more bandwidth. So all these services are available by using PSTN, that is the normal telephone system, then ISDN, narrowband ISDN, then frame relay, ATM, even internet. And when the technology was introduced, it was very difficult for a faculty member to introduce the concept of communication. Because of the internet, you will come to know many of the services you are using now, PCs, to connect with the other end. And the technology, now people are using it already. And how this is happening, let us recollect that circuit switch service, that is the oldest. Circuit switch is the oldest kind of technology. Simplest and oldest endpoint to endpoint connectivity in a wide region. So we can create MAN, that is metropolitan area network or wide area network. In that approach, this is established. And it uses public switched telephone network, PSTN. So in between, what we see is the PSTN. This is provided by common carriers like in America, etc. it is AT&T. In here it is BSNL, or many private players are there. Railway network is there. All that is the common carriers used. A power grid, railway network, private carriers like Reliance, all these people are having, along with the BSNL, the network and MTNL, this connectivity. And this is what we are using when we are talking to other end. So what we generally do is we dial up to the nearest ISP, that is the carrier. And ISP stands for Internet Service Provider. So nearest ISP we connect, and these two kinds of types which are used, these pods for plain or telephone system or services, then all services integrate together, that is voice, data, fax, everything together in network, and that is what is called ISDN. Now, basic architecture uses a cloud architecture, meaning that users connect to a network, and what happens inside the network, that is, the inside the network is like something like cloud, which is hidden from the user. So user need not generally understand to communicate with the tools. A user using a computer or modem, they just dial up and to another computer and create a temporary circuit between the two to make the communication. When the communication sessions is completed, the circuit is disconnected. As when lights are used, we switch off the lights when it is not required. And let us see that what ISDN stands for, or what are the objective, benefits and services to an extent architecture. Wherever we are using ISDN, we will see two kinds of usage of ISDN. One is the narrow band, that is the bandwidth is very limited. The other one is broadband. So along with ISDN, these words are used. B stands for broadband, N stands for narrowband. So B-ISDN and N-ISDN. So generally this narrowband ISDN uses two kinds of connectivity. That is, one is called PRI, that is prime rate interface, other is broad BRI. And in broadband, it is established by using ATM. So ATM we'll discuss later once we go through the basic of ISDN. I also invite your attention to recollect what is LAN, that is local area network. Small geographical area, you create the network. When we are extending this to bigger region, we call it as WAN. And in ISDN generally combines on this kind of circuits voice, video and data over the same digital circuit. That is more important. One cable is used between connection. The same cable is used for all these three together. That's why could be the reason it is called integrated. All the services are integrated or single line. So integrated digital network, ISDN. ISDN provide digital dial-up lines that work much like analog lines. Like a simple telephone line, it works. Whenever digital signal is to be transmitted over cable, we need to convert that signal into digital data into signal. So for that purpose, we need a modem. So we need an ISDN modem which sends signal transmission, which sends the signals. First offered in the 1970s, if you look at the history of this. And because of the lack of standardization, it was not used, and it was also relatively high cost in that time. And narrowband ISDN offer two types of services. One is called BRI and another is called PRI. BRI stands for Basic Rate Interface. PRI basic access services, generally two connections are used, 2B, and that is two B pipes, then one data for signal, and provide two 64 kbps bearer B channels and one 16 kilobytes control signals, that is called D channel. So wherever architecture is mentioned about ISDN, it will be 2B plus D, or it could be more 23 plus D when the bandwidth is more. So in the initial side it is 64, that is base rate interface, and second one is prime rate interface, which stands for primary access, and which uses 23 B bearer channel and one D for one signal control channel, and this provides 64 kbps B channel. So we can multiply 23 into 64 and 164 kbps D channel. So this is how the BRI and PRI is getting connected in ISDN. And the principle of ISDN support voice and non-voice application using a limited set of standardized facilities, and support of switched and non-switched applications, and everything relies upon 64 kbps connection. And ISDN seems to be more intelligent than other technologies, and layered protocol architecture. We can even read ISDN similarly like OSI Layers, and there are different types of configuration available. One configure, let us see that how. I want to use ISDN and I have my equipment with me, that is one is telephone, another is the data terminal computer, then I have an EPBX common exchange for telephones, then I have the LAN connectivity. This is what is the setup in my office. All this has to go through a single line. So at my place, it is marked as customer, I need to use an ISDN interface there. Till ISDN interface, it is connected with the local connections. Then from there, it will be connected to ISDN central office. Most probably that will be your exchange. And there is a digital pipe between the customer endpoint and the central office. So that will be dedicated when the loop is on. So that is what is called subscriber loop. This term subscriber is very common in telecommunication industry, because subscriber means you subscribe for the services. Like that, there is subscriber loop, and the channel BDN is established. Then we can send whatever services we require, packet switched or circuit switch or other network. But basically, as shown in the picture, this is simple architecture. Now, by establishing this architecture, we can have telephony, that is analog, speech online, and data transmission, any kind of data, or facsimile, then video conferencing. And services are generally categorized in three. One is the user-based, that is bearer services. Other one is tele-based services, that is telephony, telefax, telex, teleconferencing. And supplementary services, which is generally used in telephone system, call waiting, message handling, reverse charging, all these are supplementary services also supported in ISDN. Now, conceptual view, a little elaborated picture than the half of the up to central office, it is correct. From there, it will be switching over to packet or digital, depending upon the use. So these are whatever I have marked in arrow is called digital pipe, we call it. Generally, it is referred with bandwidth, and there is an exchange connected here. PBX is the exchange communication. Now, looking a little more detail about B-ISDN, broadband ISDN. It's a circuit switch service that uses ATM to move data. That's why ATM also included in this. So broadband ISDN, if you want to have more bandwidth, then we have to use a technology called ATM on this ISDN. So B-ISDN is a backwardly compatible with the ISDN, with a narrow ISDN and ISDN. So there are three B-ISDN services which are currently offered. One is full duplex channel. Full duplex means both and the speed will be same. Then full duplex channel at 622 Mbps. So we can have 155 Mbps plus 622 Mbps in this broadband ISDN. Asymmetrical services with two simplex channel. That is, if it is symmetrical, then we get bandwidth. Here, asymmetry means upstream is less and downstream is more. Many times, if you look at the services, people provide this kind of ratio in the bandwidth, because everybody will be interested to download rather than uploading something. So download will be at least 4 times bigger than upload. So we will see that 1:4 connection, 1 for upstream, 4 times download stream. So 1:4 kind of connection. And here it gives little more detailed view with other terminals are used. Between terminal and the digital exchange, you have a network termination, NT, or the equipment is called NTE, network termination equipment. Even modem can be called as an NTE. So subscriber interface to the ISDN through the line. It goes to the digital exchange. There will be an ISDN switch, subscriber loop. Then depending upon the speed, here it has shown from 64 kbps onwards. Then ISDN switch on the other end of the exchange, and between these two switches, the data, whatever signals are used, it is used, it is transmitted. Then subscriber other and get whatever signal we have. This is the architecture, and we'll just look at that. Subscriber premises is noted outside the box. The rest of the things happening with the network in the ISP level. And B channel have 64 kbps. D channel will be either 16 or 64. And there are channels available now, H channel also, 384, 145, 1920 kbps. Now ISDN channel structure the bandwidth according to this. So BRI generally have 144 kbps, that because that use only 2 B channel and plus 1 control channel, D channel. D generally stands for the control channel. Now T1 PRI, the T1 is the term used in telecommunication trunk line. So the minimum PRI T1 lines consisting of 23B plus 1D. So here D is 64 kbps, B also is 64 kbps. And E1 PRI, which gives Mbps speed, 2 Mbps. These are different between T1 and E1 is the notations used in America. When it is in America, the lines are called T1. If it is in Europe, it is called E1. This is only the difference. And B is bearer, D is data channel. Now ISDN channel structure has this basic and primary. So management rate will be this. Standard throughput will be, management rate is 192. Standard throughput will be 144. And the composition B plus D channel for basic. And primary, as shown in the earlier picture, this picture will clearly give how these lines get bandwidth, what kind of bandwidths are used on different channels, B, 30B and 23B channels. And looking at the user end, what a telephone equipment, that is TE1, is connected to network terminal, from there to the next network terminal, then again to the next terminal. Like that it will be, every network will be terminated with the next end where it is to be connected. At the end it will go to another TE. And here, if you look at it, you have a terminal adapter also between this endpoint. So this is what is that UNI configuration, generally, user network interface configuration. Now, let us see the protocol and architecture used here. Those who learned the OSI layer, OSI uses 7 layers. So I have shown in the left side the 7 layers starting from application to physical. So basic level is that fundamental physical level, which generally talks about the lines and its signals used in the physical level. So B, D, H channels, etc. is specified in the physical level. Over that, when it goes up, we will be using that how data is split, like frames are created or cells are created, etc. And all this at end-to-end user interface that all is combined in ISDN. So the 7 layer of OSI layer is mapped to these 3-4 layers of ISDN. Now protocol with the ISDN layer. This picture gives more. After physical layer, the next layer is ATM layer. In back, this slide you have seen that after physical data link network transport, instead of this, here it is physical, then ATM layer, then ATM adaptation layer, then high layer, other high layers, and control panel. This is how when you are looking in the layer, the concept. If other side, if you are looking, it is management plane and other synchronization mechanism. So connectivity between point is called triple P, point-to-point connectivity, PPP. So dedicated circuits are created to get it. If you remember, when you take internet connection from BSNL, in olden days, they used to connect a shell account. That shell account actually is called point-to-point connectivity. Every time you have to dial and you get the connection between these two by using an account and then. So that kind of technology was using. The T carrier is, I just mentioned again, the term from telecommunication. It may be stand for trunk carrier. So T carrier circuits are most common dedicated digital circuit used in America, etc. And T carrier also has different speed. T1 circuit, T2, T3, T4 and fractional T1. And if you look at the speed, you can see 1.544 Mbps in T1. And when it goes higher, T2, it is 6.3 Mbps, then 44 Mbps, and T4 is 274. Up to T3, we can take it as an example from various countries. T4, still we have to explore it, whether it is available. This gives little bandwidth plus the other digital signal, DL. So T1 carrier use DS1. The notation is only different. T1 is equal to DS, T2 equal to DS, because sometimes you use T1, sometimes you use DS, depending upon the country. And this is the speed of the connectivity. And packet switch network protocol, there are 5 protocols in use for packet switcher. That is X25, the basic, and asynchronous, frame relay, switched multi-megabit data services. Then finally, the Ethernet or IP packet network. X25, etc. we are not discussing because it's not there, very common also. That's why it's not included now. But we'll discuss ATM. And from the different point of protocols, S21 is the oldest one, which was very slow. That is why ATM evolved. Typically 1 to 600 Mbps is possible in ATM, while X25 if you are using maximum is 2 Mbps. And somewhere this frame relay is used, and it is faster than S25, again slower than ATM. So frame relay also has been replaced by ATMs in many carriers. Ethernet and IP services, that is like internet services. Now looking at the data rate and its cost, etc., you can see that if you want more reliability, then you need to have high cost. And in some simple circuit switching, it is ports are very low cost because it's only used for ISDN moderate and B-ISDN. If it is to increase, then high cost. In dedicated also, if you are using T carrier, it's moderate, and if you are using a optical based, fiber based connectivity, then it is high. Then packet switching. So what I'm telling is the first two are circuit or dedicated switching based, circuit switch based technology. The last one is packet. All the data is split into packet and it will send across. And the X25 frame relay, SMDS, Ethernet, ATM, all these are this packet switched network. Now after finishing ISDN, let us see that what is ATM. ATM stands for asynchronous transfer mode. That is the switching and transport technology of B-ISDN. Broadband ISDN, we have seen the speed in the architecture, and the goal was to provide high-speed access to business and residential users, starting from 155 Mbps to 622 Mbps. And this integrate all the services like voice, data, video, image, even animation, etc. The concept of ATM is ATM create virtual circuit. Virtual means the circuit is not physically available. It creates a circuit by technology and tier it of the circuit when the job is over. So focus on bandwidth allocation in compared to that IP. The more bandwidth is used, that will be allocated and created whenever it is required. So ATM main role today is switched link layer over IP over ATM. And as mentioned, ATM is a virtual circuit transport. It uses all the data in the small cell for transmission easy. And you will see that it uses only 53 bytes. Out of that, 5 bytes is for header. The 48 bytes are for data. And in IP over ATM, permanent PVCs are created, virtual circuits are created between two IP routes. And scalability is a problem with ATM. Then switched VCs are there, switched virtual circuit for short-lived connections. What is the pros and cons of this VC approach? Pros means it can guarantee quality of performance to a connection. When there is a connection, we need to check for the quality, and the quality is maintained when you have an VC approach. But what is the problem with the ATM? Insufficient support of datagram traffic, and PVC solution does not scale up, and SVC introduces excessive latency on short circuit. Benefit: ATM gives high performance wire hardware switching, dynamic bandwidth for burst traffic. When there is more traffic, more bandwidth is allocated. Class of service support for multimedia and scalable speed, network size, and used in commonly LAN or WAN, and opportunities for simplification via VC architecture. And moreover, ATM is internationally approved standard and its compliance. If you look at the 53 bytes which I mentioned as a data packet, you can see that the 48 is completely used for information, and 5 byte, that is for identification, virtual private circuit identification, VC identification, HEC, altogether 5 bytes are used for the header. Now comparing, earlier we compared ISDN with OSI layer. Here I am again taking that OSI layer in the 7 layers in the left, and you have physical layer, ATM layer, ATM adaptation layer, then high layers. Now the last technology which we discussed today is DSL. We have discussed about ISDN as well as ATM. Now the commonly used telephone wire is used for data communication, that is called DSL, digital subscriber line, and this generally connect a home user with the internet to an exchange to get the data over it. And internet is very popular with this kind of technology. So many times you will see that all the carrier like BSNL etc. offer this kind of DSL technologies. And the advantage is that if the exchange is very close, you get a very good connectivity. And generally there is a limit. If it is more than 5 kilometers, this technology may not work, DSL, to get connected. So limited distance to the central office, dedicated line from your office to home, and both way asymmetric flows are there, and typical speed up to gives only 1 Mbps speed on downstream. There are 4 or 5 variants of DSL. One is asymmetric DSL, second is symmetric DSL, then high bitrate DSL, and very high bitrate DSL. And technology used in the DSL is out of scope of this small duration talk. Now asymmetrical DSL is something like which divides up available frequencies. You have so many frequencies in the line, so what it will do in the line, all the frequency it will divide up on the assumption that most internet users look at or download much information than they send or onward. Under this assumption, if the connection speed from internet to the user is there to 4 times faster the connection from the user back to internet, then the user will see most benefit out of it. So it is not symmetrical in both way, asymmetrical. I mentioned that 1:4 ratio. ADSL is asymmetric communication technology designed for residential user, and business it is not because you don't get high speed on download on upstream. And it is an adaptive technology. The system uses data rate based on the condition of the local loop. An existing local loop can handle up to 1. And here also the technology is same. If you have a telephone equipment, what you need is an ADSL modem. So the moment you apply for a connection, they will provide you a modem, and telephone company, and up to that you get a local loop. From there it will go to ADSL modem, then ADSL modem will send the data. If it is voice, it will directly. So a filter is there to see that whether it is voice or data. Data means it will pass through the ADSL modem. Now this is how a connection look like. When you have a computer that is through an Ethernet cable, it is connected to a modem. From modem it is connected to a telephone socket, and from telephone socket for analog signal you are connecting to phone line. So phone will work just like anything, or when it is data it will decide and send it. This is the simple setup which is required to use a telephone connection by using ADSL technology for data network. And limitation of this technology is distance sensitive. The limit for ADS service is 18,000 feet. That comes to 5.4 kilometer. That is theoretical limit. But if you see that it is 5 kilometer, 4 kilometer, the signals are getting very weak, diluted, and it don't reach the destination. At the extreme of the distance limit, ADS customer may see speed far below the promised maximum. So even if it is meant that if you connect a 5 kilometer with the speed of 2 Mbps, you may not be getting the speed. Even it will be half or maybe quarter of the speed which is mentioned. And customer near the office will get a faster connection. So this is what about the various technologies used. And we have discussed how copper wire and that old telephone system is used for data network, and the data network based on ISDN, ATM and DSL technology is discussed in this module.